Our objective for today, I can factor polynomials completely. Let's read it together. 1, 2, 3. I can factor polynomials completely. So today is going to be a culmination of everything that we've been doing in regards to factoring. So today is going to be applying all the skills to each problem every step of the way to see if we see any patterns, anything that we've done in the past such as GCF, and all the factoring procedures. Okay? So that's why we don't need a Ferrer model and we don't need steps. Yes?
I've always wondered, what does CFU stand for?
That's for me, and that's just checking for understanding. I just want to make sure that you guys are understanding what we're doing. Okay? That's why we have an objective, to make sure that you guys understand what we're doing for the day.
So what is the concept for today's polynomials?
We're factoring. Yeah.
Okay.
All right, so here we go. So with that said, we don't need the Ferrer model. We know what polynomials, and we focus on quadratic trinomials, right?
Yes.
We don't need this. We don't need steps. I gave you guys steps. However, look at these steps, though. Look up, please. With any factoring that we do, what is the first step that we look for? GCF. Is that correct?
Yeah.
All right. However, look at step 2. Look at step 2. It says, check for patterns. I put that in there because we did that last week. We were checking for patterns. And what patterns did we find? Perfect square trinomial and difference of squares. Only 2, right?
Yeah.
However, look at the rest. It's still the same. Open to parentheses, factor the first term, power rangers, write your factors and check. So everything still is the same. The only thing I included here was to check for patterns, but that's just so that you want you guys to follow that process. Okay? So with that said, copy this first example down, please. Example number 1. And it says, tell whether each expression is completely factored, if not factored. And this one is 5x cubed minus 10x squared minus 15. Copy the instructions, please, at least for this one. Copy that. So it says, tell whether each expression is completely factored, if not factored. We're going to do this one together. Here we go. Let me zoom in. So let's find out to see if it's completely factored. And our first step, everyone. Step 1. Everyone. GCF. So therefore, what number divides each term? 5. Is that the only thing that each term has? Yes. So therefore, we open up parentheses. We're left with x to the third minus 2x squared minus 3. So step 1 is done. Step 2 was to check for patterns. Remember the patterns from last week? The first pattern that we would check to see if it's a perfect square trinomial. Can I take the square root of the first term? So this is a no. The only time we can take a square root when there's a variable, if this number is in, and I want you to make a note for yourself, if that was an even, then we can take the square root. But is it an even number? No, therefore we can't. If we can't, then we move on to the next step. Let's see. The next step would be to open two parentheses. And let's see. Can we factor the first term?
Yes.
No, because this one needs to be a what?
2.
A 2. Therefore, since we don't have a pattern, we cannot factor it. Therefore, we stop right there. And we're just going to write completely factored. So when we cannot find a pattern or cannot factor it using the 2 parentheses, the power range and all that, then we're done. Everybody got it? So what are my factors? Here, the factors here are 5. And let me move this over. My factors here are, well, 5 times x cubed minus 2x squared minus 3. Those are my 2 factors. Why? Because aren't they multiplying right here?
Yeah.
Yes, that's why they're factors. Let's go to the next one. Copy this one. You don't have to copy the instructions anymore. Copy this one. 7x cubed plus 28x squared plus 21x. Copy that. Here we go, example 2. Let's do this one together.
7.
Step 1, GCF. What number divides each term?
7.
7. However, does each term have a variable x?
Yes.
Yes. And what is the smallest power on all these variables?
X.
X to the first, so therefore we're going to use that for our GCF, x to the first. So let's see what we have left. 7 divided by 7, it's 1. And what is x cubed divided by x? That's x to the second. 28x squared divided by 7x, that's 4x. Plus 21x divided by 7x, that is 3. Are we there so far? Okay? So step 1 is done. What is step 2? Let's check for patterns. Let's see. Square root of the first? Yes, it's x. Is that correct? But before I do that, let's check the last one. Can we take the square root of the last? No, therefore we cannot use the pattern. But can we use the next step? What would be the next step? Open two parentheses. Remember, if the patterns don't work, continue factoring as we've always done. So, can we take the factor the first term? Yes, that's x and x. Over here, let's draw our Power Rangers. This is a 4. This is a 3. Factors of 3 that add up to 4. 1 and 3 or 3 and 1. So my factors are x plus 1, x plus 3. But don't forget about the BFF, 7x. And then you just write completely factor. And we're done. How are we doing?
Great.
Yes? Okay, once again, let's go over the steps to make sure that we got the process. Step 1, GCF. Step 2, we check to see if it has a pattern for perfect squares. It didn't. Step 3, we continued, open two parentheses, factor the first term, and then use the Power Rangers to factor the last two, and that's how we get our factors. Yes?
Wait, so when do you know when to put the 4 on top or the 3 on top of the Power Rangers?
The last term always goes on top. Always. Or if it has the leading coefficient, you multiply the first times the last and it goes on top. Let's do another one. Example 3. Copy this one, please. And right now we're going to copy example 3A.
3A?
That one.
Right, example 3A.
Yeah, example 3A.
3x
And it's 3x squared
times 6x minus 4.
times 6x minus 4. Okay? So, this one might be a little confusing. Pens down, eyes up here. And this is why. Our noodle, usually when it sees something like this,
Distributed from
automatically we think to distribute. But we're not multiplying in this unit, are we? We are doing what? Dividing, which means we're finding greatest common factors. Therefore, according to them, pay attention please, they're saying that this is the GCF. So right now I'm going to check in here to see if there's another GCF. I'm not going to pay attention to this right now. I'm going to look in here. So look at the 6x and negative 4. Is there another GCF? Yeah, what is that? 2. I open up parentheses. And what's left? 6x divided by 2, that's 3x. Negative 4 divided by 2, that's negative 2. Are we there so far? Hold on before you continue. Pay attention, please. I said, according to them, this is the GCF. But for right now, we're not going to pay attention to that. We're focusing in here. Is there a GCF in here? Yes, it's 2. 6x divided by 2, that's 3x. Negative 4 divided by 2, that's negative 2. However, they already had a factor, and that factor was what? 3x to the second. So now that we have two factors outside, what is 3 times 2? 6. I bring down the x squared and the parentheses. And now it's factored completely. Copy that, please. Or completely factored. Copy that. All right. So, That was example of 3A, is that correct? I'm going to give you one very similar before we do 3B. Right next to it, I want you to draw a line down like so. I'm going to write example 3Q. 3Q. I want you to check to see if this next one is factored completely. Here we go. 7y to the fourth, parentheses, 18y minus, 30. Check that one and see if it's factored completely. If not, factor it. Copy that and go. According to this expression, this factors the GCF, but let's double check in here. Is there another number or another GCF in here? What is it? 6. And then you open up parentheses. 18y divided by 6, that's 3y. Negative 30 divided by 6, that's negative 5. Are we there so far? But we bring down the other factor, 7y to the fourth. So what is 7 times 6? 42y to the fourth, and 3y minus 5. Those are my factors, so now it's factored completely. Hands if you got that by yourself. Okay?
What? Wait. Oh.
7 times 6. Remember at the end to multiply numbers with numbers, variables with variables. Okay, let's move on to the next one. Example 3B. Yeah, 3B. Copy this one, please. Example 3B, parentheses, x squared plus 1, close parentheses, open parentheses, x minus 5. All right, let's do this one together. Let's start first with this parentheses. Look up the first one. Is there a GCF for these two, a number that divides those two other than 1?
No.
No. Does each one of these terms have a variable? No, only the first one. Step 2, check for patterns. Can we check this one to see if we can take the square root for this one and this one? No, why not? Because this one is an addition. We can only do that if it was like this. Remember that? What is this called? Difference of squares. Since we can't take patterns or factor anymore, then we're done with that one. Let's move on to this one. Let's see. Is there a GCF for these two?
Yeah. No.
Other than 1? No. Does each term have an x? No. No, only this one. So now, let's check for patterns. This one is a difference. Can we take the square root of the first?
No.
Why not?
Because it's not B.
Because it doesn't have a what? An even number exponent. Therefore, since we cannot factor it anymore, guess what? It's completely factored. All right, let's move on to the next one. Example 4. Example 4, there's A and B. See if you can do those by yourself, please. Example 4, A and B. I'll zoom in. It says, check to see if it's factored completely. If not, factor it. Go. All right, here we go. I'm going to go over this one again for those of you that just walked in, just to make sure you're caught up. What we're looking for to see if this is completely factored. What they are saying is that this is a GCF. So therefore, to check to see if that's true, we need to go to this one and see if there's a GCF in here. Is there a number that divides both terms other than 1?
No.
No. Does each term have a variable? No. It's a difference, so let me try the pattern. Can I try the pattern for difference of squares? Why not? Because it doesn't have an even number exponent. Therefore, if there's none of those, then at that point, I'm done, and you write completely.
Yes! Yes! I got it
Factored.
right.
Good.
High five.
Completely factored. No, that's all right. That's all right. All right, here we go. Let's go with 1B. We're going to start with this. According to them, this is already completely factored. But let's look at this one first. Is there a GCF for the first parentheses? Yes, it's 4. So therefore, let's see, 4x divided by 4 is 1x, plus 4 divided by 4 is 1. Let's see, can I do anything else with this? No, and that one looks the same as this. I bring this one down. Is there another way of writing this?
4x to the first, plus 1 squared.
Hold on. 4x plus 1 squared. And now it's completely factored. Good. Okay, let's move on to the next one. That was example what? 4? 4B. Okay, copy this next one, please. Copy this one, example 5. It says, factor 10x squared plus 48x plus 32 completely, and check your answer. So this one, they're asking us to check the answer. So we're going to do that at the end. So, no, just copy the trinomial, but remember at the end we're going to check our answer. Okay? So let's see. Here's our trinomial. Let me make some space here. Alright, so we have 10x squared plus 48x plus 32. So let's see. Step 1. Edgar. What do? For every time that we factor, what is the first thing we do? GCF. What is the GCF that divides into each term? What number divides 10 that divides 48 that divides 2? Does each term have a variable?
No.
No, so that means just a number. So we open up parentheses, and we're left with, let's see, 10x squared divided by 2, that's 5x squared, plus 48x divided by 2, that's 24x, plus 32 divided by 2, that's 16. Okay? So, at that point, can we check for a pattern? Let's see, can we take the square root of 5? No, so we can't. That means we're going to continue, open two parentheses. Since we cannot factor the first term, why can't we factor the first term? Because it has a coefficient greater than 1. That means that I'm going to go straight to my Power Rangers. I have 24, and on top, what goes on top? Let's see, 5 times 16, that is 80. So let's see, 1 times 80, 2 times 40, 4 times 20, 5 times 16. So that one is 4 times 20. Does everybody remember what we're doing now?
Yes.
We're going to rewrite this one here, and the last term here, the only thing that's going to change is what? The middle term, is that correct? Be nice. So I write 5x squared. Instead of 24, what do I write?
4x squared. 4x.
Plus 4x.
20x.
Plus 20x plus 16. Alright. So let's see. Now let's start all over. What's GCF for these two? X. And we're left with 5x plus 4. What's GCF for these two? 4. And we're left with 5x plus 4. So according to what we see there, let's see, close parentheses, what's the same here and here?
5x plus 4.
5x plus 4, which is here and here. And what's left over out here? X plus 4. And we get that from here and here. However, don't forget about BFF, which is 2. And now it's completely factored. However, what was the part of the instructions that we said not to forget? check. We're going to check. So let me zoom out, and we're going to check together. And by now we should know how to check. Is that correct?
Mr. Q, that was all multiplied by 2, right? Multiplied
Right, by 2. So then at the end we're going to check. So let's start with the area model. So what are my factors first? 5x plus 4 and x plus 4. So let's see. 5x times x, that's 5x squared. 5x times 4, that's 20x. 4 times x, that's 4x. And 4 times 4, that's 16.
That's 5.
So let's see what we got. Let me move this out of the way.
Don't forget the peanut.
Yeah, I know, hold on. Here it goes. First term is 5x squared. I'm going to draw my peanut right here. 20 plus 4, that's 24x. And I bring down the 16. Am I done? No, don't forget about the BFF, which is 2. And we distribute. This becomes, I'm going to write it over here, 10x squared plus 48x
Plus 32.
plus 32. Did we end up with what we started? Yep. And that's a home play for tonight. All those different examples. So, for home play, I gave you guys from page 525 from the red book, so that was numbers 2 to 30 even. Let me put that page so you guys can see it on the video.
Dude, I got
There it is. Numbers numbers 2 to 30 even, and just follow the instructions. Okay? Alright guys, enjoy your homework. See you guys tomorrow.